about an important topic in conditional probability. This is related to something that's called Bayesian analysis, but we're not going to get into the depth of that. We're talking about the headache criterion as a diagnostic or screening criterion for COVID-19. So let's just frame the problem first. We're talking about the problem with using headaches as a screening criterion. So the idea of this presentation at the beginning is that headaches are a screening criterion for COVID-19. They're often listed on a checklist of symptoms. Do you have this symptom? Do you have that symptom? The problem is incidental headaches are quite common. And so the presence of a headache doesn't indicate for very much. So it's hard to tell whether the headache is a useful screening criterion or not. You might think that because headache often co-occurs with COVID-19, that it would be a very useful screening criterion. You might think because headache is very common, that the presence of a headache doesn't by itself really mean anything. So it's hard to intuit the right answer to this question. What we're going to do here is we're going to use this as an opportunity to talk about some conditional probabilities and how we would do the mathematics behind these conditional probabilities in order to try to get a better answer to this question. So here are some of the probabilities involved with this question. First of all, we have two fundamentally different events. We have the COVID-19 infection event and we have the headache event. Now those can both occur, or only one of them can occur, or neither can occur. Then we have many probabilities involving them. The probability of H will be the simple probability of a headache. This is the probability that any given person has a headache at any given time. Probability C, that's the probability. Here I'm putting this in the context of New York State because that's where we live. This is the probability that somebody in New York State has COVID-19. And to be specific here, this is a test confirmed COVID-19 because in order to assess this probability, I'm going to use the count on confirmed cases. This is at any given time, not throughout time. This is not the probability that you have had COVID-19 sometime in this year. It's the probability that one would have COVID-19 right now today. And I should mention, because everything is constantly in flux, today is October 14th for me. So the video may get dated when we learn more information. Then we have conditional probabilities. The probability of H given C. That is the probability that you have a headache given that you have COVID-19. So if you're in the unfortunate situation that you have a test confirmed positive case of COVID-19, this is the probability that you would have a headache as a result. We would expect this to be high because headache is a classic symptom of COVID-19. Then we have the reverse conditional probability, the probability of C given H. This is the probability that you have COVID-19, given that you have a headache. So the only thing we know about the person is that they have a headache and that they live in New York State, I suppose. And then in the presence of this knowledge, we're asking, then what is the probability that they have COVID-19? And then finally, we have one last probability relating these two, and that's the probability of C and H. This is the probability that you are so unfortunate that you have a test-confirmed positive case of COVID-19 and a headache. We would expect this would be the lowest of these probabilities because that would be the most unfortunate situation. Anyway, we have some practical estimates for some of these things, and they don't have the same quality here. I want to caution you about that right away. The probability of having a test-confirmed COVID-19 positive case right now, based on yesterday's data, that is based on the data of October 13th, 2020, is about 0.0036. That's about 0.3% probability. I'm getting that from this fraction here, 72,000 divided by about 19 million. This numerator, this 72,045, is, according to the New York State website, the number of active cases of COVID-19 in New York State right now. And I'm dividing by the approximate population of New York State. So this is the simple count on the number in that category divided by the total, and that gives us a probability, 0.0036. If we want that expressed as a percent, it's somewhat less than 1%. It's about 1/3 of 1%. Now, this is the part, so COVID is very, very well measured and well studied, especially right now. Headaches, incidental headaches, headaches with no other comorbidities it's harder to get good data on that because they're very minor and they can be very often very minor. They can be serious, but it's hard to get really good data on headaches. And so it's not exactly a wild guess, but this 0.02 is basically my guess for the probability that any given person has a headache at any given time. I'm ballparking that at 2%. And if anything about this video is wrong, it's probably that number, because that's really just my guess. So I want to caution you up front. What does that mean about the conclusions that we make here? That means that these conclusions are hopefully a pretty good way to learn about probability and statistics, hopefully a pretty good way to learn in principle how the science of this would work, but the specific medical conclusions that I might draw from this guess, we cannot trust because the guess is wrong, right? So this is in principle how we would do this calculation, but I don't want you to trust in this number because that's based on my guess. The next number, the probability of having a headache given that you have COVID-19, is actually much better measured. I found an article that pegged it at about 13%. So that means the probability of H given C is about 13%. That is, among COVID patients, about 13% suffer headache as a symptom of COVID, which is of course much higher than the percentage of people that would be normally experiencing the headache symptom. So I've got a little code cell down here in which I input this data. So the PC means the probability of COVID, PH means the probability of a headache, PH given C, that's this thing, and that I pegged that at 0.13 or 13%. Okay, so these are our estimates for the probabilities. Now, where does the math come in? Well, principally the math comes in by means of our most important equation for the conditional probability. And I'm using that equation in two different forms. We have this equation for conditional probability. The probability of A given B is the probability of both divided by the probability of B. So I'm using that in two different ways here to assess the probability of H given C and to assess the probability of C given H. And so notice here we have the probability of both divided by the probability of C. And here, when we do this reverse, we have the probability of both divided by the probability of H. Now, both of these equations are true. And we know certain ones of these, right? We know, for example, the probability of H given C, that's what is measured up here. That's about 0.13. And the probability of C, that's what's measured up here. These are actually both pretty well measured right now. And so we get pretty good information about this probability here. Sorry, not the H. We get pretty good information about this probability here, the probability of H given C, that's this 13%. And pretty good information here, the probability of C, that's this 0.0036. And so what we don't have is the probability that any given person would have COVID-19 and a headache, but we can figure that out from what we do know. If we know these two parts of the equation, then we just multiply both sides by P of C, and then we calculate this thing as the product, P of H given C times P of C. And that's exactly what I'm doing here, right? I'm taking P of C, and I'm multiplying it by P of H given C, which is this thing. And then that's going to give me the probability of H and C. We calculate this, and we get 0.000468. And this really reflects that it's not very likely that a given person would have both COVID-19 and a headache. So that's a rare event, right? If you pick a person at random, it would be very rare for them to have both the test positive COVID and the headache condition. Now, okay, so that's interesting. That gives us the probability of having both of these things. Can we do anything else with this? Well, we have this reverse conditional probability, the probability of COVID given the headache. And that's also a ratio of two things. The first of which we just calculated, and so now we know. And the second of which is probability of headache, but we don't have good data on it, but we do have a guess. And so what we can do is we can just plug in what we just calculated for this thing and what we calculated for this, what we guessed for this thing, and we get a decent guess for this conditional probability. So, so we take this thing that we just calculated and we divide by the probability of a headache, and then that gives us the conditional probability. And that conditional probability is 0.02. Now, I want to talk about what on earth that means. That's a 2% probability, and it's a conditional probability too. So this is the probability that a person chosen at random has COVID, test positive COVID, in fact, given that they have a headache. So in other words, this is a pretty decent measure of how likely it is that you would have a COVID-19 infection if you have one of these classic symptoms, if you have in particular the symptom of the headache. And there are two things I want you to notice about this number. It's both very small and very big, and I want to explain what I mean by that. First of all, COVID is a tremendously significant condition, and so even a small probability of it is a tremendously important thing, right? So 2% is very big, is a very big probability when it comes to something that's really important. Um, it's big in another sense. It's big because it's quite large compared to the unconditional probability of having COVID-19, right? Which is less than 1%. It's about 1/3 of 1% here. So this is fully 2%. So basically, the probability of having COVID has increased from less than 1% to 2%. And it has increased because we had more information. And the information that we had was that we have one of these classic symptoms. And that indicates, I won't say that it proves, it doesn't prove, but it indicates in favor of that diagnosis. So this is very large compared to the probability of having COVID if we didn't know anything about whether you have a headache. However, it's also a very small number. It's only about 2.5%. So what that means is if you have a headache, well, you probably don't have COVID, right? Like one should probably, so I mean, with probability 97.5%, right? If headache is all that you have, if the only information that we are really acting on is the headache symptom, then almost certainly we're not dealing with a case of COVID-19. So this is kind of strange, and it's difficult to have the right intuition for what to make of this, right? The probability of having COVID if you have a headache is much higher, but it's still very low. And so I think when it comes to practical conclusions here, it's difficult to know what to make of this. I would say that the headache symptom allows us to revise the probability of COVID-19 upwards quite significantly, but it still only gives a fairly low probability. So what should we make of this? Headache is a useful screening question because it really is informative about the probability of COVID. But it's a really bad diagnostic criterion. If a doctor is gonna accept a patient into their office and say, well, do you have a headache? Yes or no? And you say yes, oh, well, you probably have COVID. That's a really irresponsible diagnostic criterion. So it's a really bad diagnostic criterion because it doesn't prove anything, but it is a useful screening question. And if it were the only screening question, then it would not be worth much. But if it's paired with a lot of other screening questions, then together they could have a lot of value. So I think what we should make of this is that evidence is useful even if it's weak evidence, right? I would say that the headache criterion as an indicator for COVID is very weak evidence, but it still is some evidence, and therefore it has some utility. Now, in medical practice, and when we're really doing things right, of course, we're not trying to assess the probability of some diagnosis on the basis of one criterion. We have many criteria, and we lump them all together. And so, what we're really trying to assess is the probability of some diagnosis given a long list of symptoms and the absence of other symptoms. Combining all of these things is much more complicated, but it can be done using the same kind of mathematics that I just illustrated in principle. And it also is kind of done intuitively by experienced professionals, right? Doctors are familiar with the lists of symptoms, and they can kind of intuit. I mean, the doctor might not be able to tell you the exact probability, right? If they say, I think this is indicative that you have this condition, they might not be able to further say, oh, that's with probability 87%. But they would be able to intuit the answer to the question by combining their intuitions for these conditional probabilities. Expert systems on computers can do this using the precise mathematics, and that's sometimes useful as an assistive tool for the doctors, but it certainly isn't a replacement. All right, so the long and the short of it is conditional probabilities allow us to assess the usefulness of our evidence and revise our probabilities of certain unknowns in the face of evidence. A 2% probability should be interpreted here as both very large and very small. It's very small in the sense that it's only 2%, so probably not. But it's very large in the sense that it's much larger than we would have had without that evidence. And so weak evidence, although weak, can still be very useful. Thank you.